Propagation of sound. We have seen how the sound is produced. Sound is produced by vibrating objects. The vibrations of the object produces sound. Now we see how this sound propagates. The sound is propagated through the vibrations that are happening in the medium. So basically what happens is, the matter or substance through which sound is transmitted is called a medium. So the medium can be air or water or solid. So it can be solid, liquid or gas. So if it is a gas, it is in the air. So we see mostly the sound waves in the air. So even in our tuning fork example, so the vibrations that are happening on the vibrating prongs are basically making the air particles closer to the prongs compress and expand based on the vibrations. When it is moving back and forth, the air particles or air layers next to the prongs start compressing or expanding or rarefacting based on the back and forth movement of the prongs. So when an object vibrates, it sets the particles of the medium around it vibrating. Remember that the particles do not travel all the way from the vibrating object to the ear. The prongs do not travel all the way, but the sound waves travel. The vibrations passes on the sound from one particle to the other till it reaches the ear. What basically happens is, a particle of the medium in contact with the vibrating object is first displaced. Take for example the tuning fork. So the particle very close to that prong gets displaced from its equilibrium position. Then what happens? It exerts a force on the adjacent particle. So what happens because of this? The adjacent particle gets displaced from its position of equilibrium, and once it gets displaced, the adjacent particle exerts the force on the next particle to it. Like that, it goes on. But as it is going on, as this transmission of this force is happening, the original particles, once it exerts the pressure or a force on the adjacent particle, then it comes back to its position. So it means that these particles as it is do not move. They just pass on the information, pass on that force onto the next object for it to vibrate. So the vibrations get carried over, but not the particles as such. That is the most important thing we need to remember. So this process continues in the medium, in this case the air, till the sound reaches our ears. So how it happens? Let us see it with an example of tuning fork. So let us explain to understand the propagation of sound in the medium, and we will select the medium air. So we will see how sound waves in air propagate. Let's take a tuning fork with the prongs A and B, and this is the way its original position is. When it is silent, the sound is not produced, and with its prongs in normal position, and we will see original position of the air layers. So the air layers are evenly spaced out, and this is the original position. Now we produce a sound in the tuning fork. When the sound is produced, this is the outstroke of the prongs. What do you mean by outstroke? Because when a tuning fork is hit hard on a hard rubber pad, then it moves back and forth. So when it moves away from the handle, then we call it as outstroke. When it moves towards the handle, we call it as instroke. Now, the prongs A and B are outstroke position. What happens? So, this vibrations created by the tuning fork, let us take for the discussion only the prong A. So, the vibrations created by the prong A compresses the air particles, or we can call it air layers, and the layers are consisting of particles, and it's all the air molecules basically, and they pass on the force onto the adjacent particles, and then they come back to their position. So when they pass on the vibrations onto the adjacent particles, the compression of the air particles is created. So this is what happens during the outstroke of prong A. What happens during the outstroke of prong A? There is a compression of air particles that happens closer to the prong A. So when prong A moves out, compression of the air particles happens. Now the in-stroke of prongs. That is, the vibrations happens towards the handle, inside. Then what happens? There is more space created because the prong A has gone inward. So the rarefaction happens. The particles will start coming back to their position. And the compression happens after certain layers. So what happens basically in a continuous out and in strokes? Rarefaction and compression, rarefaction and compression. So it goes on continuously on alternate basis based on the back and forth movement of the prong. So the vibrations are getting passed on and the particles will come back, and again next layer will get compressed, again they will come back, again next layer gets compressed. It is because the energy is getting transmitted, transferred through this process. So the force is basically getting passed on from one air particle to the other, but the particle by itself does not move. So we know that we hear a sound from a flute or sitar. The flute or sitar, the object does not move to our ear. Only the sound that is created by the vibrations of those strings or the air inside the flute travels through the medium like air and then reaches our. So that is explained by this tuning fork. So in this continuous out and in strokes, we see the compression moving towards the right side, but the air layers do not move bodily. So the air layers keep vibrating back and forth at the same place. So they are vibrating back and forth at the same place. They do not move bodily, but these compressions and rarefactions move towards the right. So the net result of a sound producing body, in this case the tuning fork, is that it sends the waves consisting of alternate rarefaction and compression. So the net result is, in a continuous out and in strokes of the tuning fork, then the net result of vibrations is it continuously sends alternate rarefaction and compressions. When these waves of compressions and rarefactions of air fall in our ears, the eardrums vibrate accordingly. So when these things only fall in our ears, our eardrums vibrate accordingly and produces the sound. Actually, the eardrums reproduce the sound. Since they vibrate in the same manner like these compressions and rarefactions, and then it is basically a decoding gate. So it reproduces the sound. So that is how this happens. So this net result of vibration create alternate compression and rarefactions, reach our ears. What happens in our ears? So the eardrums vibrates accordingly. I mean, eardrums vibrate accordingly in the same manner as these rarefactions and compressions came up from the tuning fork. When it does, it reproduces the sound. So we understand from this that the propagation of sound through a medium like air, how these compressions and rarefactions happened. The air by itself does not move. The air particles are where they are, but they will be having back and forth movement, and by which the energy gets passed on, and then we get these low pressure areas and high pressure areas are created. The low pressure areas are rarefaction, high pressure areas are compression. It is also linked to the densities, because higher the density, higher the pressure. So when it is compressed and more particles are there, so density is higher, so the pressure is higher. So it gets released. Again it becomes low pressure area. So it continues like this, and then the sound gets produced in our ears with the vibrations of eardrums.